All right. If you punch this into your calculator, and Crystal knows now that that is 9 exponent button to the 1/2, 1 divided by 2, you will get 3. If you punch this into your calculator, which would be 27 exponent button, bracket 1 divided by 3, you will get 3. If you punch this into your calculator, 625 exponent button 1 divided by 4, you will get 5. And of course, you already know that 9 to the 1/2 equals 3, and the square root of 9 equals 3. And you know that 27 to the 1/3 equals 3, and you know that the cubed root of 27 equals 3. And I'm out of room, so I'm not even going to do that with this one. Of course, you also know that this mathematical notation is a radical, and it is missing that number right there, which is called the index. That index, when there is nothing there, is a 2. In this case, it is a 3. You also, of course, already know that this 9 is missing an exponent, because there's an exponent that we don't write. What is it? 1. So, of course, you remember that 9 has a 1, the index has a 2. There's a 1, there's the 2. The 27 has a 1, there's the 1, there's the 3. Right? So all of you remember that this symbol with some index and x to another exponent is the same. That is the radicand. It becomes the base. This power becomes the numerator, and this becomes the denominator. I am not going to show you why, because the y isn't coming into use until next year. And I don't want to crowd your brains. Now, I know I have told you many times in the past that I always show you why. But grade 11, we start to get more and more compressed for time. So that is where I leave it. Now, every other rule still applies. So let's look at this very first one. Of course, what is wrong with that? It's a decimal. We hate decimals. You all love decimals because you hate fractions. You should not hate fractions. Fractions are much easier to deal with. This is, of course, what in reality? 4 over 100. To what power? 3 over 2. Now, what is the base? 4 over 100. What is the exponent? 3 over 2. Now, if this exponent was just a 2, where would it go in this fraction? It would go to both, because we already know that law, yes? So, if something looks different in math, do we treat it differently? No, because math always works. So if it was just a 2, it would go to everywhere. So this must be 4 to the 3/2 over 100 to the 3/2. Correct? Okay. My denominator is 2, which means where does it go when I rewrite this? It's the index. Where does the base go? It's the radicand. And where does the numerator go? It's the power. Right? Over the square root of what? 100. To what power? What is the square root of 4? 2. What is 2 cubed? What is the square root of 100? Cubed. 1,000. Would I leave it that way? No, of course I would not, because 8 will simplify and 1,000 will simplify. You would bring that down to 2 over, no, I lie, sorry, 1 over 125. Now, of course, do I have to go through all of this? No, of course not. I don't have to. There's other ways I could do this. Why am I showing you all of it? Because now I'm covered. My glutes are covered. Right? If you see a shorter way to do this for you, should you use it? Yes. As long as what? It works and you can explain it. Because if you do something differently than I showed you, and you get the wrong answer, what's the only thing I can give you? A big old wrong, right? Okay. Most of these on this page you will be able to do in your head, right? So let's go. What's going to happen here? That is going to become what? Cubed root of 27 to what power? 4. What is the cubed root of 27? 27, not 24, idiot. 27. 3 to the 4th power, which is what? 81. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. What's weird about C? It's got 2 exponents, right? But again, we know what to do. If I had 8 cubed squared, what would I do with the 2 and the 3? So what am I going to do here? What am I going to do here? Multiply. What is 1/3 times 2? 2/3. And then this looks exactly like what we've been dealing with. Cubed root of 8 squared. What is the cubed root of 8? 2 to what power? Which is 4. What bugs us about D? It's a decimal. But of course we know that that's 49 over 100, yes? And it's all to the 1/2. Well, where does the exponent go? Square root of what? (49) over what? 100. All to what power? 1. What is the square root of 49? What is the square root of 100? Done. What is happening in E? The exponent's a decimal, but we don't care about that. We hate decimals. What is it really? 3 over 2. 1 and 1/2, yes? What is the square root of 16 cubed? 4 cubed, which is 64. And lastly, what is that 0.75 really? 3/4. 4th root of 81 cubed. We already know the 4th root of 81 because we just did it in B. What is the 4th root of 81? 3 cubed, and that is 27. Now, you will notice that I am expecting some memory of how to do this when they're ones that are perfect, right? Right? You will also notice that I have a whole second tab here on radicals. So we're going to be going over and going further with radicals if you don't remember how to do these. These ones are all perfect, so it's not too much of a problem, yes? Everybody cool? All right, now, this one, what's wrong with it? It's not perfect. As a matter of fact, it's kind of impossible, isn't it? Because that would be the fifth root of 8 squared, wouldn't it? Does 8 have a fifth root? What's the biggest root you can get out of 8? You can get a cubed root out of 8, right? Because 2 times 2 times 2. Can't get any smaller than that, yeah? So this is where we have to recognize that 2 can live in 2 different places. It can live there, or it can live under there. So if it's under there, then I get the fifth root of, what is 8 squared? 64. And that does have a fifth root, doesn't it? Because 64 is 2 to the 6th. And what does that little 5 mean? I can bring out 5 of these 2's. 2, fifth root, and what did I leave under there? A 2. This is the math class answer. That is where we want you to get. If you don't remember how to do it, you needn't worry because you know we're going to review radicals. That is not a physics class answer. Physics class, you would do the calculator and get this decimal. Everybody understand? Everybody cool? Same thing here. Now this one doesn't get any prettier. Or does it? That would be the 7th root of 0.6 all to the 15th. That bugs us, doesn't it? But what if that 15 were under there? Now can I do it? How many groups of 0.6 can I get out of there? 2 of them, right? Because there's 7, group of 7. So I would have 0.6 squared, 7th root, what did I leave under there? 1.6. Everybody with me? Again, math class answer, the decimal is your physics class answer. Clear? All right. Skip the next thing, it's a waste of time. But go halfway down that page. To remind you, do any rules change when the looks change? No. This looks different. We haven't dealt with a decimal base. But we do notice that those are the same base, aren't they? So if I had x to the negative 3 times x to the 5, what would I do with those exponents? Add them to get what? X squared. So what am I going to do here? Exact same thing, 0.3 squared. Would I stop there in this question? No, why not? Because it's a number, so I can evaluate it. Now, if it was a big or an ugly number, how would we evaluate it? With a calculator. But we don't need one here, right? What is 0.3 squared? 0.09. Why? Because that's 3/10 times 3/10, which is 9/100ths. 0.09. Everybody cool? Yeah? Yeah. Does number 2 scare you? It looks a little scary, doesn't it? But is it? What do you notice there and there? They're the same base, so can't we just follow the regular rules? Isn't this the same as x to the negative 4 squared and x squared cubed? So isn't it negative 3 halves to the negative 8 and negative 3 halves to the 6? And then what would I do with those exponents? And what would I get? What there bothers me. Which negative? The negative exponent. What does that negative exponent do to its base? So I now have 2/3 squared. Does that negative disappear? Really? Is it part of the base? Is it a positive exponent? Is it an even exponent? Does that negative 2 negative disappear when I square it? So what would I end up with? 4/9. Is everybody cool? Is anything mathematically new coming to the party? What's the only thing that's come to the party? Different looking numbers. And we live in Canada. Everybody's welcome. All these numbers are welcome. What am I going to do there? Do I need to be scared that there's decimals? I don't, do I? It's all the same base, so what do? Follow the rules. 3 and 4, 1.4 to the 7th over 1.4 to the negative 2. Now what? 1.4 to the 9th. Now, since that's a number, should we technically evaluate it? Should we technically evaluate it? Do I want to see it evaluated, or do I care about the exponent laws? I care about the exponent laws. Do I know you can all push 1, 2, 3, 4, 5 buttons on your calculator? Do I know that? I do. So if you got to there, I'd be happy. Why is number 4 going to scare all of you? Oh, fractions. And what's the hardest thing in math? Fractions. Oh no. Do we need to be scared? What should I do down in the denominator there? What should I do with that 1/3 and that 5/3? Add them to get what? 6/3. Are those the same base? So what should I do with those exponents? What is 2/3 take away 6/3? Negative 4/3. What bothers me there? The negative exponent. My pen has stopped working. Man, do I hate it when that happens. Oh, Ashneet, that was good. You know what? I've had this damn thing for years. Nobody has done that gag. I don't even think I've done that gag. That's funny. It still doesn't work. Anyways, what would I do with that negative 4/3? What happens to this 7? It reciprocates, so I get 1/7 to what power? To what power? To the 4/3. There will be 2 videos today. One will say part 1, one will say part 2. While I restart my computer, because of course